So what this means is something like oh, mortgage payments or car loan payments. So when you have a loan, it doesn't have to be a loan, it could be another example of annuity, but just this is one example where let's say you buy a house or you buy a car. Let's say you bought it for 100,000, even 100K, right? So you are now going to be paying monthly regular payments to pay off that, car or house or whatever. And that is an example of annuity because the sum of the money that you're paying is, let's say it's going to be 100,000. Let's say the total after buying the car and paying the interest over whatever 10 years. Let's say you take a 10-year loan for the car. So a 10-year loan purchase the price of the car with interest and final thing is 100,000. So yeah, so that means the sum of all your payments is going to be 100K. So that's an annuity. It's basically making regular payments every month, and then at the end of it is calculating the total amount that you paid for that thing. So like you could buy a car for say 60,000, but in 10 years you could end up paying like 80,000 for it because of interest, right? So we are going to learn how to calculate exactly how the banks and like when you go to the bank to get a loan or if you go to a dealership and when they calculate your loan amounts. I mean, it's all software. It's all computers. You can do it in spreadsheets and you can just Google it. Now, to be honest, you don't have to do it manually, but you're gonna learn how to manually do it. Which today it's cool. It's kind of. I mean, I don't know. I've done it. So yeah. But you're right. You can just Google it and just plug in the metrics and you can just figure it out yourself. Oh wait, sorry. This is investigate. I don't like investigates. You know, they're pointless. Here we go. Boom. Example 1. And for these type of problems, these annuity problems, pretty straightforward, especially in grade 11. You guys really don't do anything too difficult. All you need to know is the formula, which is this. Actually, is there a better? Hold on. I think if there's a better formula. Where the heck is it? Does this not do it? Oh, here it is. I guess the same formula doesn't really. Oh, no, here, yeah, this is what I wanted. So what I wanted was with the formula, but representing what each variable, stating what each variable represents. So the amount of an annuity can be calculated using formula A is equal to R, bracket 1 plus I, close bracket N minus 1, close bracket all over I. So I and N are the exact same thing as the previous lesson. I is your interest, represents your interest rate per compounding period, important, as a decimal, and N represents the number of compounding periods, and R represents the regular payment, and A is the total amounts that the annuity is going to be. So let's do an example now, so hopefully you'll understand it a little bit better. So at the end of every month, Hoshi deposits $100 in an account that pays 6% per year compounded monthly. He does this for 3 years. Draw a timeline to represent this annuity. This is important, actually. I glossed over this. Drawing timelines, especially if you take economics in university. So for those of you who are going to be in business, this is Econ 101. You got to draw your timeline. How do you draw a timeline? Easy. So every month, right? So this is N is equal to 3 years times, since J is 12 monthly, times 12, which is 36. That means in total you're going to have 36 deposits because it's 3 years, you're doing for every month, 3 times 12, 36 deposits. So when N is equal to 1, I'm going to show you here a nice little timeline here. So here I'm going to explain exactly like the concept, the theory behind the math. All right, say today is now. This is Mr. Hoshi living his life today at the first of, this is the first of the month. First of, doesn't really matter what month. July, August, September. Doesn't matter. It's the first of the month. Now, at the end of the first month, Mr. Hoshi is going to deposit $100. Or the beginning, doesn't really matter, whatever. Whenever one starts. So, first month, you have the first deposit. Now, this $100 that he deposits initially, his first initial deposit, and he's keeping this $100 for how long? For 3 years, for 36 months, right? So that means this $100 is going to have interest accumulate on it. It's actually called compound interest. So every month that passes, this $100 is going to grow by 6% per year, compounded monthly. So how do I figure out what 6% is? What's my I value? 0.06. What's my J value? 12. If you do that, you should get 0.005. And that is this value right here. See the value inside the brackets? Well, sorry, it's 1 plus I is inside the bracket, so 1.005. But the 0.005 comes from your I value. And remember, your I value is not just 6%. You also have to take into account the J value, or the compounding frequency. So since I figure out now what my quote-unquote, true interest rate is, I know my bracket is 1.005, and I know my $100 is going to get an interest of 1.005 compounded for 35 months. So that $100 that I deposit right now, let's say today, and in 3 years' time, it's going to accumulate 35 months of interest. Because remember, this is compounded monthly. So every month, you're going to get a little bit of money. So just to show you, after 1 month, that $100 is going to have, what is that, 1.005? $100.05. 50 cents, sorry. So after 1 month with 6% compounded monthly, the account is going to have $100.50. So let's say I didn't deposit $100 every month. Let's just say I just deposited $100 in the first month. And you're like, okay, after 1 month, I made 50 cents. So that was to the power of 1. After 2 months, how much interest have I made? Well, same thing. 1.005 to the power of 2 times 100. $101, and I guess that's too low to count, so $101. $101. So roughly, I'm going up by 50 cents so far. But you're going to see that this is going to skyrocket, because that's after 2 months. This is compound interest. This is the beauty, if you want to call it that, of compound interest. Let's say if I now don't check up on this account for 1 year. 1 year. Well, not including the first month. So 11. So after 1 year's time, not including the month that I deposited, because the month I deposited I didn't make any interest. But then for the next 11 months, I'm making interest. So after 1 year's time, how much interest would this have earned? $105.64.